Two and a Half Admins, episode 28. I'm Joe.
I'm Jim.
And I'm Alan.
And here we are again. And before we get started, we've got a couple of plugs here. One is register for Open Source 101.
Open Source 101 is a conference from the same folks that bring you all things open, the biggest open source tech conference on the East Coast, back when locations mattered and people went places. It's, aimed at more neophyte users than the full All Things Open conference is, but there's still enough advanced, for everybody to get something out of it. I highly recommend it.
And you've got another blog post from Clara Systems, Alan.
Yes, so this one is about the new upcoming D-RAID feature in ZFS and what that's about and why you might be interested. It gets into why the resilvering is much different and how D-RAID solves the classic problem of RAID Z taking too long to resilver.
Right, well, there'll be links to both of those in the show notes. Let's do some news then. The first one is an interview with John Morris, the CTO at Seagate, who surprisingly says that SSDs will not be killing spinning Rust anytime soon.
Just because everybody's laptop now has an SSD or an NVMe instead of a hard drive doesn't mean that there aren't going to be hard drives anymore. They've got new 20 plus terabyte hard drives now, and they're on the road to 30 before too long. And I think they're even saying 50 terabytes by, was it 2024, 2025, something like that? While SSDs have gotten a lot cheaper, they're still 7 to 10 times more expensive than hard drives for the same capacity. And when you have to store petabytes or exabytes of data, it needs to be that. And like he says in the article here, we're actually seeing data become more and more concentrated. People save fewer of their files on their one computer and instead save them in the cloud so they can access them from anywhere, which makes sense, except for, the cloud needs a lot of storage and not all of it needs to be that fast, right? It's still limited by the speed of the internet and so on. And so they can use a lot of hard drives for that.
Yeah, now to be fair, when we say that flash storage, SSDs, NAND costs 7 to 10 times as much as Rust, that's at a given scale. If you're talking about small devices, there's kind of a crossover point. Like if you look at a 1 terabyte Rust hard drive versus a 1 terabyte SSD, you're going to basically spend $70 to $100 to get somebody to sell you a thing that qualifies as a drive, no matter what it's made out of, right? So there's not a whole lot of difference there in price. And the difference in performance, is pretty much unreal unless you've gotten a really bad solid state drive. But there's no indication whatsoever that once you get into the kind of capacity that Rust is good at, solid state is going to catch up with it anytime soon. So it becomes more a question of, at what point are you willing to pay the premium for Flash's higher performance?
And isn't that a case of caching? Like you'll have a little bit of solid state in a server that will cache the frequently used stuff or the OS or whatever, but then all of the kind of archive data will just be sitting on spinning Rust.
It can be, but not always even then. If you put together a small file server with, say 8 Rust drives in it, and they're decent quality Rust drives, and, maybe use ZFS with mirrors instead of, one big wide RAID Z, you might not really see much of any benefit out of, adding in flash caching, either for L2 ARC, or even for a log device to accelerate sync writes. Because if you're doing file servery stuff and it's mostly, large block size writes, you may find that pool on Rust is, the throughput is as high as it would be on a fast flash device anyway. So you don't really get much out of it. Where you really need the flash is, when you're specifically looking for really low latency and especially on, very small block size I/O.
Yeah, if you're doing a lot of random I/O that would make the hard drive heads have to seek around a lot, that's where Flash really has the advantage. So the use case of I need to host a whole bunch of VMs, that's where Flash can really make a difference. But if you're just hosting media content or even just stuff for video editing, then the spinning drives are probably going to give you better throughput and they don't wear out at nearly the same rate as Flash. So it really depends on the use case. And then kind of like Joe alluded to, maybe not with caching, but with tiering or some mixture, having some of your data be on Flash and the rest not really lets you get the hybrid of getting the performance you need with a cost that makes sense. Because right now, if you look at it binarily, you can have cheap lots of storage or expensive smaller amount of storage. But in general, you have some of your data that needs to be fast and some of it that you just need to keep a lot of. And having something that can handle both is interesting. And that's mostly where the commercial solutions come in that let you make a system that has hard drives and SSDs. And whether that's ZFS in the L2ARC caching type case, or the special VDEV putting the metadata on the fast device and the small blocks on the fast device and the bulk data on the devices that are better at sequential.
The whole idea of caching with SSD, that can be a thing. It's not as commonly a thing as a lot of people believe it is. And like Alan was saying, the best answer usually is to put your data where it makes the most sense. Like in my own office, I've got a moderately large SSD pool for virtual machine images and my own workstation's root drive. And then I've got a Rust pool for bulk file storage. So you put the data that doesn't need a ton of random access on the Rust, and you put the stuff that does on the flash.
Whatever happened to hybrid drives where they've got some flash storage and a bunch of spinning Rust?
They were crap. People used them, found out they were crap, and that, for almost every use case they actually had, they were every bit as slow as a regular Rust disk, and so they fell out of favor. Really that simple.
It basically comes down to that's just a worse version of an L2ARC. And as we've pointed out about the L2ARC, it's good in some cases, but if your working set, the data you're using constantly, isn't small enough to fit on it, then the system's just guessing what block you might use next. And when it's wrong, it's not any faster. And if it's wrong more often than it's right, then you're just burning up a bunch of flash as an L2ARC and not getting any benefit out of it because you're not reusing the same blocks over and over that you can keep on the faster storage. And if you're using them that often, it's going to end up in memory, not on the L2ARC anyway. The L2ARC is a second chance cache. So, if anything's in the L2ARC, it's already not popular enough to stay in the main cache. And, when we talk about flash even now, there's multiple different degrees of flash, right? We have you don't really see SLC flash anymore, but you have the MLC and TLC and QLC flash. And so as you get these, with the QLC flash, the 4 bits per cell, it lets you start to get these higher capacities, but at much, much worse write endurances. And oftentimes, it's a trade-off. It's like you can get something that'll hold more data on flash, but the writes aren't going to be as fast, and it's not going to be able to write as many times before it wears out. In which case, you're getting more and more towards, a hard drive solves the problem better.
Yeah, by the time you hit QLC, you'll notice that you don't really see QLC drives any smaller than 1 terabyte, maybe even 2 terabytes. And the reason for that is because even when it's brand new and in the best condition it will ever be during its service life, if you don't have that high of a capacity, you don't have enough parallelism between the banks to make it as fast as a Rust disk, much less any faster.
The problems that hard drives have been running into is that we've seen these capacities constantly going up, but the IOPS, so how many operations a hard drive can do, has been pretty stagnant in the 200 to 250 IOPS range. And that was fine when hard drives were 500 gigs or whatever. But now that we're talking about a 20 terabyte hard drive that can only do the same number of operations as a 1 terabyte hard drive, it gets to be a bigger problem.
So let me ask you this then. When will we get to a point where almost all servers have SSDs in them and spinning Rust is a thing of the past?
Almost all of my servers have SSDs in them for the boot drives and maybe some optimization or whatever, but they also have spinning Rust.
Yeah.
I don't know that we'll ever get to a day where you're not going to have any hard drives, because hard drives are probably always going to find a way to be cheaper.
Well, Alan, I think the key thing that you're not doing here is you're not pushing Joe on his question. You're not asking him what he means by a server.
That too.
If he means like an office file server, in my world, we're already there. Like I very rarely sell any servers with Rust these days to small businesses because I'm like at the price point for no more than 10 or 12 terabytes total of storage. I can and will absolutely sell every single small business on Flash because I don't want to deal with Rust being slow and quirky and weird. It's just not worth the little amount of money you save. If by server, you mean massive things filling racks and data centers, never.
Yeah, I think it gets back to the point that Sia was making early on, is currently about half of all storage is in data centers. But they expect over the next 5 years that number to get to 90% of all storage is in data centers. And I don't disagree with that. As I mentioned, more and more stuff moving towards the cloud or just centralizing it. There will be more data centers, and we're seeing more local data centers and things of that nature. But we are definitely moving towards more and more of the data being centralized. And when you have a lot of data, hard drives solve the problem well. If you have a lot of hard drives, you can get a lot of performance out of it. If you have hundreds of spindles, then you're getting, your couple hundred IOPS times every one of those spindles. And you can actually get good enough performance to keep whatever network link you have full without having to do a lot of SSD. Again,
assuming we're talking throughput, not latency.
Yes.
If you've got one single operation that needs really low latency responses, that's where you need the SSD.
Yep. And, all this stuff in the cloud has to be backed up somewhere too. So even if you have a lot of SSDs, you might need some hard drives backing that up. And your backup should be more than one copy of it, right? You need snapshots in time from a bunch of different times, because if you take a backup every night of that important Office document and you didn't realize until today that the copy from a Monday, somebody screwed up the file, then the only copy you have is last night, and that one's screwed up too, then you're boned. That's why you need to have a series of backups. And so you might need quite a few times the amount of total storage you have in backup storage.
Yeah, that's the one place that I do still sell Rust to small businesses pretty frequently. My typical topology is like everything is virtualized and you've got a production host, an on-site hot spare, and an off-site disaster recovery. The on-site hot spare will have the exact same processor and RAM and number of solid-state drives as production does. It's a physically identical twin. But the off-site DR machine, if the client wants to save some money or if they need a much greater archive depth, that'll absolutely just get Rust disks in it. So, you might only have 30 hours and 30 days and 3 months of snapshots on the production in the hot spare, but the offsite DR might very well have, a full year of monthlies and, maybe 90 dailies.
Right, let's talk about VR. And as your colleague Ron wrote recently, Google's last surviving VR product is dead. So this is Google Cardboard, which they are no longer selling. They've open sourced it, so other people still are, but it pretty much seems like Google has given up on VR. This comes off the back of them open sourcing Tilt Brush, which was their VR kind of painting brush program. They've given up on that and just given it to the community. It seems like they really have just given up on VR.
Cardboard itself is just what it sounded like. It was a very inexpensive physical piece of cardboard you could cram your smartphone into and do virtual reality stuff. But the actual VR platform itself was Google Daydream. And I never owned Cardboard, but I actually did participate in using the Daydream platform. I liked it quite a lot. You could go out and you could get a cheap little Daydream compatible headset and stuff your phone into it and strap it on your head. And I spent a few hours with my kids one night experiencing a VR recording of like a 360-degree camera attached to a weather balloon just going up into orbit, right? So you strap this thing on your head and the balloon is like spinning around and you're just watching the ground recede from you, for like half an hour as you go into orbit with like a little bit of time lapse here and there. It was amazing. Like you could turn your head. So it's like you're riding the balloon. They also had, some kind of low rent VR games, some of which were quite fun to play. Like, you have a virtual fire hose in your hand and you put out little fires across the town and, knock dogs off of steps and whatever. I kind of miss the platform that it's gone. Even though I have a much more powerful Oculus Quest, I enjoyed what was on Daydream.
Google hasn't figured out how they're going to put ads into it yet, so they don't really care. I think Google's probably much more interested in augmented reality, but as they saw from the backlash from the Google glasses and so on, people just aren't quite ready for that yet.
Well, people are not ready for it as consumers, but I think enterprise and industry is where Google Glass can and does do well.
It does not do well. That's where augmented reality can and does do well, but the high end there isn't Google Glass, it's Microsoft HoloLens.
Well, doing well is a relative term. I mean, they brought it back, didn't they, for the sequel of Google Glass, and they must have sold some of them. Otherwise, it would have been killed already.
I mean, by the time this show airs, who knows? It's Google.
True, with Google.
Yeah. It's also just kind of creepy that all of the tech only comes from one of these 4 companies nowadays.
There are a ton of people out there that are making AR glasses. If you don't have the budget for HoloLens, and you are cursed, as I have been sometimes, to go physically attend CES, you will see tons of booths for all kinds of people's AR glasses that work relatively well. What you really only get from, one of the handful of big tech providers is the kind of concerted PR push that Microsoft has done with HoloLens, even more really than Google ever did with Glass. I felt like Google just kind of dumped Glass on the world, like, hey, let's see what happens if we throw this thing out there in very limited numbers. Mm-hmm. Whereas, Microsoft has really made a push to get HoloLens on people's heads and get industry interested in it. And I think that's paid dividends.
Yeah. And I think one thing that the AR stuff benefits from is having access to a large database of information to be able to augment reality with.
Yeah, I've seen some pretty compelling applications where, like, if you're a field tech that, works for, like plumbing, mechanical engineering type stuff at larger scale, like you can walk onto a factory floor and, you can look at a physical pipe junction and have a gauge pop up, like a virtual gauge that tells you what, internal sensors are measuring for pressures and temperatures there. You can look at another part that needs servicing and, have a field guide literally pop up as a window by it, highlighting which bolts you need to turn in which order. Yeah. That's pretty awesome.
There's been times where I've wanted a version of that would remind me of people's names, but the facial recognition stuff is just too creepy. Yeah, it wouldn't be fair for me to have access to that, I think.
Okay, this episode is sponsored by Linode. Go to linode.com/2.5 to get started with $100 free credit and 60 days to use it. Linode offers cloud computing solutions in data centers all over the world. Whether it's scalable VMs with a choice of major distros or one-click apps and stacks, dedicated CPU and high RAM instances, block and object storage, or cloud firewalls and DDoS protection, Linode has everything you need for your personal projects right up to managed enterprise infrastructure. I recently moved my website over to Linode and it was really straightforward. And when I needed a Mumble server for our Late Night Linux community meetups, spinning up a new VM for that was an absolute breeze. Everything's been running flawlessly since I set it up, and I love the peace of mind I get from the automatic backups. So go to linode.com/2.5, get your $100 credit, and check out Linode's great cloud hosting services and first-class, always available support. That's linode.com/2.5. All right, let's do some free consulting then. If you want to send your questions in for Jim and Alan, show@2.5admins.com. And if you want to support creation of these episodes, go to 2.5admins.com/support. And thank you everyone who is supporting us. And remember, for $5 or more per month on Patreon, you can get an advert-free RSS feed, so check it out. So the first one is from Florian. I have a question regarding I/O weight on Linux machines versus Windows. A task with high I/O load on a hard disk can render a Linux machine completely unavailable. This can be something like a large copy or rsync process. How come that on a large multi-core server with 128 gigs of RAM, everything stands still? Even a LXD container on a different disk. Yes, they share the same kernel, but also 64 CPU cores. Even an SSH login might time out. The nice command helps, but is that really all I can do? It's been many years since I worked on Windows, but I don't remember something similar there. Can you guys explain why Linux behaves the way it does, why this is supposed to be the best solution, and why Windows doesn't, or does it?
All right, so one thing at a time. Windows absolutely behaves the same way, if not worse. The easiest way to witness that is take a Windows laptop with an old Rust drive, copy a ton of tiny files from one folder to another, and see how responsive the desktop is.
Hey, Alan, why don't you do that right now on your Windows machine?
It's got NVMe, so it's fast.
Yeah. So, if you do that, everything will be fine until you need to hit the hard drive. And as soon as you do, everything slows down to a place of complete horror because you've exhausted all your IOPS on the first process. Now, the other thing is, you say that your machine will bog down with an LXD container on a different disk from the large copy or rsync process you made. And I don't think that's quite accurate. At the very least, I certainly cannot reproduce or confirm that behavior. If you tie up all your IOPS on your root disk and then you go to access a completely separate disk with data on it, that will be fine as long as you don't need to access something on your root drive again. If you do, then you're going to bind on that and it's going to be slow. Now, the other thing is Linux is infinitely more tunable for that than Windows is. You can set your I/O scheduler. You can set your I/O priorities. You can do an awful lot to reduce the kind of I/O weight problems you're talking about when you've got a very heavily loaded system. By default, Linux systems are usually configured with, I think they're still configured with CFQ for Rust. Depending on your file system and depending on the hardware, your default I/O scheduler might be Deadline instead. And Deadline is configured for lower latency. CFQ is generally configured for higher throughput at the expense of higher latency, but CFQ itself can be configured. Now, Linux distribution vendors generally did not tune CFQ. They shipped it with its own defaults, which prioritized throughput and not latency, which made for a terrible desktop experience. That's an awful lot of words to basically say, I don't think it's quite like you think it is, and yes, Windows is as bad or worse.
Yeah, like in general, what can be happening is you're doing a large copy or whatever, so you've queued up a whole bunch of commands to the disk saying, read from here, write to there, or whatever, and it's got, there's basically imagine like a store, and there's a line out the door of things waiting to be done. The line's moving, but if you want to do something new, you're at the end of the line, and you have to wait until you return to the front. And then they tell you, oh, you also need this other thing. So go to the back of the line and wait again. And that's how you end up with the system seeming to be that slow, even if that's just reading your shell from the disk in order to be able to SSH in.
Yeah, and the 64 CPU cores and 128 gigs of RAM doesn't do a thing to give you more IOPS on your storage.
Now, the buffer cache should mean that, if somebody has used the shell today, it's probably in the buffer cache. But outside of that, yeah, it's, all those CPU cores are probably relatively idle waiting on your disks. If you've built a machine with 64 CPU cores and 128 gigs of RAM and all you're running on it is an SD card, it's going to be slow.
Yeah, the other thing that we ought to tackle is you said the nice command helps. And for the problem you're describing where you've got high I/O weight, the nice command is not what you're looking for. You're looking for the IO nice command, which will take processes that you're willing to push further into the background and make them less likely to consume all your IOPS when you've got another higher priority process that needs to run at the same time.
Yeah, and like Jim was saying about tuning, a lot of it comes down to the hardware. And there's no default that works great for everyone. Because if you have very fast disks, especially very low latency disks, you need to queue up a lot of commands to keep them busy. But if you have a slow disk, like a hard drive, and having to seek a lot, then you want a shorter queue depth because you want to ensure that when something new and important comes up, where you maybe have used IO nice to make it go to the front of the queue, so it gets to butt in front of the line, you don't want it to be stuck on too many other things that it was still doing before it can get to that high priority thing. And, ZFS has some tuning for this too, to make sure that sync writes go in ahead of async writes. And it will make sure that it never has more than 3 async writes outstanding, so that if a sync write comes up, it can go right to the front of the queue and get done as quickly as possible.
Okay, Gregory writes, I'm contacting you for what I thought would be a solved problem, clustering under Linux. I've been using Linux for almost 20 years, mainly on desktop and personal servers. Recently, I started a sysadmin position in a small company trying to move their infrastructure from Windows to Linux. My first task is to move their file server to Samba. I tried to do a Samba cluster, CTDB, monitored by Pacemaker and CoroSync, and DRBD for file sharing between both servers. I know that 2 servers is not really a good cluster, but the docs seemed to say it was okay. The setup was easy, all seemed fine, but as soon as a security update gets installed, the whole thing falls apart. Cluster goes down, Pacemaker outputs cryptic messages, even reboot is a pain, it gets stuck forever, I need to power off the VM manually. I also tried the same approach for a web server and PostgreSQL as a backend, Pacemaker, DIB, CoroSync, and it was a nightmare. How come clustering is not a solved problem in 2021? Do you have any recommendations on how to do clustering?
Distributed computing is hard. Depending on your scale, clustering is basically a solved problem. Where it's not a solved problem is for, one lone wolf sysadmin who, wants to set up a thing at a relatively small scale with a couple of boxes. High availability in general is not a good fit for that use case, much less clustering. Like if you were really, really determined to do high availability there and clustering, you would probably should be looking at like a distributed file system like Ceph or Gluster instead of just doing Samba on top of DRDB. I don't recommend that either. It's still too much complexity. It's too much maintenance. It's too much hassle for one person to be on top of. You need a team for that. And in a lot of cases, you probably don't need a team for that because you really shouldn't be doing it anyway because it's just not worth it.
Yeah, like with all clustering and HA type things, there are X variables and you can optimize for some fewer number of those, right? Are you clustering because you need more performance? So you need to have more separate machines because no one machine can do all that, in which case, you can optimize for that, but then you also want to optimize for, I don't want to have to buy, 8 times as much storage as I actually have as usable because I don't want to have, 4 copies of every block in order to make sure that I can read it from 4 different places and have it be fast. Or, I need, when I do a write, that it shows up everywhere quickly. It's like, well, if it's got to be written to a bunch of different places to make sure that it wins in the cluster, then you're going to have to wait until that's done and it's going to increase latency. And so basically everything's a trade-off. And especially on your smaller scale, like Jim was saying, you can't have all the things you need to make it work. The biggest danger with having only 2 there, it's split brain, right? If both machines think they're the master for a little bit, then they each accept writes and now they're both wrong and you have to decide which one to keep. And there's not really a way to manually reconcile them. And so you're just screwed. That's why you usually want to have at least 3 so that there's some quorum that wins. But either way, you can end up with some of your data going bye-bye, and that's not what you want either. So I would agree with Jim as well that DRBD type thing is probably not what you want for a cluster. That's more of a way to do a mirror between machines. It's not really a cluster. And even for Postgres, for your database, if you do want to do that, probably something more like having Postgres with this binary replication set up means that you have this database and that database server, and you have to deal with your application knowing which one to connect to, or doing some kind of reverse proxy type thing. But trying to have 2 machines access the same block device and have the database running on both, that's a recipe for unhappy times.
Yeah, my guess here, just based on the fact that Gregory is, kind of self-describing as a lone wolf, operating as a sysadmin in a small company, he didn't say, but I don't think he's looking for performance. It sounds like he's looking for high availability. And I'll give him the same answer that I've given, at this point, literally thousands of people at conferences, which is, high availability is not really what you want. You want high reliability. You want a low RTO, recovery time objective, and you want a low RPO, recovery point objective. It's not going to be a good fit for a lone wolf to have some kind of crazy automated, self-failing over multiple node infrastructure, because it's going to break and cause you headaches more often than it's going to save, it's going to save you. But if you've got like a production and hot spare setup, like I talk about all the time, that very frequently replicates between the two of them in a way that you can monitor. And if production falls over, you can very easily, push a button or two and spin hot spare up as production yourself. You no longer have this split brain scenario, because now when you have a big problem, your human brain comes onto the situation and says, oh, production is down. No, it's not worth spending the time trying to bring production up right now. Yes, it is worth losing the small amount of data, from the time from my last replication to the hot spare. So I'll just promote hot spare and be done. Now you can deal with production in your own time and get that up in your own time. But, you still only had to be down for a minute or two for you to address it. And it was very easy, very predictable. The fix is the same way every time. It achieves all your objectives without introducing a new layer of complexity to screw you over.
Exactly. You want to have it set up so that in less than half an hour, you can get the new stuff all switched over and lose less than 10 minutes worth of data and be in control of when it switches back. Like you were saying with Pacemaker and CoroSync and giving these cryptic messages, it's like, exactly. It's going to give you this cryptic stuff when something goes wrong and you're going to not know what to do. With a failover thing like Jim was describing, you control the big switch and you decide when it flips over and when it flips back. And it doesn't try to do it by itself, and it doesn't do back and forth, and the two don't argue with each other. It's the big switch, and it's the railway switch. It goes this way or it goes that way, and somebody has to pull the lever to make it change. It can make your life a lot easier. It's easier to document. It's easier for someone else to pull off. And it doesn't break every time you try to install a software update.
And it also performs better because you don't have DRBD getting in the way of, you trying to commit writes and what have you.
Yeah, you're not adding latency to every write, waiting for it to be replicated on the other side. You say, I'm willing to give up the last 5 or 10 minutes of the data after the crash or before the crash in order to do it asynchronously and not have the performance penalty.
Right, well, we'd better get out of here then. Remember, show@2.5admins.com if you want to send your questions in or your feedback. You can find me on Twitter @Joe Ressington.
I'm @JRSSNet.
And I'm @Alan Jude.
We'll see you next week.
Bow, 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 bow.